Welcome everyone to this lecture where we're going to have an overview of the project exercise tasks. Let's head to the notebook and have an overview, and in the next lecture we'll have the solutions. Okay, here we are at the exercise notebook for the dbScan project. We're going to be working with a dataset from the UCI or UC Irvine Machine Learning Repository Archive, and it has some data on just wholesale spending from customers in Portugal. And we can see here we have some information about how much annual spending they've been doing in a particular channel and in a particular region. So we have different categories of fresh product, milk products, grocery products, frozen products, detergent papers, and delicatessen. And then we have the different channels. Note that is technically categorical. So we could say they're coming in from a channel such as a hotel, restaurant, or cafe, or some nominal channel. And then we have different regions of customers of different regions of Portugal. So we're going to go here, and you can see the relevant papers as well, is just complete the tasks in bold below. And we've set up the importing of the actual data set and imports of the libraries already for you. So once you import this, you should see a data frame that looks like channel, region, and then the different amounts here, and we can see DF info as well. And then after that, you'll do some exploratory data analysis. You'll see the relationships between various categories. You'll also color them by channel. Then we'll see here as well as a distribution of milk by channel. Then we'll have you do some cluster and hierarchical mappings here. And then we'll have you also create a pair plot. So once you're finished with the exploratory data analysis, you'll move on to dbScan. Now, something we haven't really mentioned yet is typically, even with something like dbScan that is not density-based, we do have this epsilon feature, which is looking a distance out from a point. And if you're dealing with a data set that has a variety in different orders of magnitude, for example, if you decide to just leave regions as encoded as 1 and 2 or 3 and 4, etc., instead of one hot encoding them, because there's so few channels and so few regions, it's actually not a big deal to leave them as numerically encoded. You'll notice that the values here are an order of magnitude different than the values for these grocery spending. So what you probably want to do is, because epsilon is a distance-based metric, then you can just standard scale everything or normalize everything to get rid of any issues pertaining to the epsilon value. So we'll come back down here and we'll ask you to just use standard scaling to scale the data. And whenever you're in doubt if a machine learning algorithm needs scaling or not, just go ahead and scale. It's not a big deal that way. Okay, then we'll have you use dbScan, and you're going to essentially copy what we did in the lectures and use a for loop to create a variety of models that are testing different epsilon values. We show you the range of values that we tested. We go from 0.001 to 3, and then you'll also set minimum number of samples equal to 2 times the number of features. We will leave it up to you whether or not you want to one-hot encode or use dummy variables for channel and region, but you should note for the purposes of this exercise, we just left them as numerically encoded because there were so few numbers of regions and channels. Then you're going to create a line plot of the percentage of outlier points versus the epsilon value choice. Should look something like this, really familiar from the lectures. So notice as epsilon value increases, suddenly your percentage of points classified as outliers will greatly decrease. And then you're going to choose some epsilon value. For our solutions notebook, we chose an epsilon value of 2 as the point where you're not seeing any drastic changes in percentage of points of outliers. Then you'll create a scatter plot using the labels that are discovered. So notice here, these are no longer just the channels or regions. This is actually the labels that dbScan has discovered. And you should know it kind of matches up quite nicely, but it does identify outlier points, which is kind of interesting. Then you'll create a scatter plot of milk versus the detergent papers, colored by the labels. Again, you can clearly see the outliers. It is interesting to see some outlier points here closer to the cluster. So you may want to be thinking, well, what's the difference between the features of these outlier points versus the other 2 clusters? Or what's the difference between one cluster 0 and one cluster 1? So what we end up doing is you'll create a new original data frame, essentially the original data, but now you're going to connect it to the labels because they're all connected by the index position. So you should be able to match those up correctly. And then you're going to grab the statistical mean of the clusters and outliers for spending amounts of the categories. So note here, we have this. Then, in order to fairly compare the two, we'll go ahead and use a min-max scaler to min-max these from a 0 to 1 value. And then this will allow you to eventually create something that looks like this, which will show you just how different the outliers are. Essentially, the outliers are kind of at the max possible of all these grocery values of fresh milk, grocery, etc. So essentially what this is telling you is you should discover the outliers are just people that are spending a lot. So it's whatever particular customer channel, they're just outspending pretty much any other cluster, which you can see from the actual plots as well. They're just way out there in terms of spending on both milk and detergent paper. So we'll come back down here and then we'll say, go ahead and create another heat map similar to the one above, just comparing cluster 0 and cluster 1 and see what are the actual features that are quite distinct between the two. And we went ahead and did a min-max scaling just so it's easier to read the actual differences here. If you really want to, you could also do this in the original units to compare the actual dollar and annual spending amounts themselves as well. But what were the two spending categories or the two clusters the most different in? You type that out in Markdown. You should be able to kind of easily see it here. It's really just going to be the main values of grocery and detergents and paper. Okay, that's it for your overview. Let's go ahead and head over to the next lecture where we go over the solutions after you've given it a fair shot.